Today, we will discuss about the basic outline of computer network. Basically, networks are like digital highways connecting computers and devices to share information and resources. If we want to go to an accurate definition of it, then a network is a collection of interconnected devices that can communicate and share resources like files, printers, or the internet. Let's check out the history of network. Early network emerged in the 1960s for military and research purpose. Over the times, technologies like Ethernet and Wi-Fi lead to the widespread use of networks in business and homes. MCQ question which answers you have to write in the comment section. The question is, what is the primary purpose of a computer network? Option number 1, to perform calculations faster. Option number 2, to connect computers and allow them to communicate. Option number 3, to increase the storage capacity of a single computer. Option number 4, to operate software without the need for hardware. Uses of computer networks. Number 1, resource sharing. Network allows users to share files, printers, and other resources, eliminating the need for individual copies on each device. Think of a network as a central library where everyone can access books and information. Number 2, communication. Networks enable communication between people through email, instant message, video conference, and social media. Think of a network as a giant phone system connecting everyone globally. Number 3 is entertainment. Networks support online gaming, streaming services like Netflix, and access to vast amount of entertainment contents. Imagine a network as a giant entertainment hub, offering movies, music, and games on demand. MCQ question. Which of the following is a primary use of computer network? Option 1, data processing within a single computer. Option 2, facilitating communication and resource sharing between multiple devices. Option 3, performing calculations faster than a standalone computer. Option 4, reducing the need for physical hardware. Give the answer in the comment section. Standard organizations. Basically, organizations like IEEE, that is Institute of Electrical and Electronics Engineering, defines communication protocols, set of rules that devices use to understand each other on a network. Imagine traffic laws ensuring everyone on the road understand how to move safely and efficiently. Other organizations are IETF, that is Internet Engineering Task Force. Next one is ISO, International Organization for Standardization. And next one is ITU, International Telecommunication Union, etc. MCQ question. Which organization is responsible for developing and maintaining the TCP/IP protocol? Option 1, IEEE. Option 2, IETF. Option 3, ITU. Option 4, W3C. Give the answer in the comment section. Protocols. Protocols are a set of rules and conventions for communication between network devices. The Hypertext Transfer Protocol, that is HTTP, is a protocol used for transferring web pages over the internet. When you enter a URL on your web browser, HTTP defines how the browser communicates with the web server to request and receive the web page content. Examples of different protocols are TCP/IP, that is Transmission Control Protocol / Internet Protocol, which is the foundation of the Internet, and Wi-Fi, which allows wireless communication between devices. Think of a protocol as the specific language device used to communicate and share information. Line configuration. Basically, it refers to the physical arrangement of cables and devices on a network. Imagine it as the layout of lanes and intersection on a highway. Now, it has two types. Number one is point-to-point line configuration. That is a network configuration where a dedicated communication line connects exactly two devices. Example of it is a direct cable connection between a computer and a printer using a USB cable, where the communication occurs solely between these two devices without any intermediaries. Number two is multi-point line configuration. That is a network configuration where multiple devices share a single communication line or channel. Let's take an example of it. In a shared Ethernet network using a hub, multiple computers are connected to the same hub, allowing them to communicate with each other over the same physical cable. Network topology. It refers to the logical layout of a network, how devices are interconnected. Imagine it as the overall design of a road network, not just the physical engagement of cables. Example of it. Common topologies include bus, where all devices connect to a single cable. Number two, mesh, where devices connect to multiple devices for redundancy. Number three, ring, where devices form a closed loop. Just think of a bus network as a single main road, a mesh network as a web of interconnected roads, and a ring network as a circular highway with traffic flowing in one direction. There are other two types of networks are also there, like hybrid, which means combination of two or more networks, and another one is tree, where hierarchical structures are maintained. MCQ question. Which network topology features a central node that connects to all the other nodes? Option 1, bus topology. Option 2, ring topology. Option 3, star topology. Option 4, mesh topology. Give the answer in the comment section. Periodic analog signals. It defines the electrical signals that vary smoothly over time and can be represented by a sine wave. Think of a wave on the ocean with a smooth rise and fall. It is just like that. The key concept in the sine waves are characterized by their amplitude, that is height of the wave. Next one is frequency, that is number of cycles per second. Next is phases, that is position of the wave at a specific time. And last but not the least is the period, that is time taken to complete one cycle. Just imagine the wave's height, how often it repeats, where it is in its cycle at a specific moment, and how long it takes to complete one rise and fall. Composite signals. This type of signals formed by combining multiple sine waves with different frequencies. Just think of a complex ocean wave with multiple smaller waves riding on top of it. If we connect it with a real life example, then the sound of your voice is a composite signal made up of multiple sine waves at different frequencies, just like the way I am modulating my voice while explaining the things. Categories of networks. The first one is LAN, that is Local Area Network. It connects devices within a limited area like a home or office. Just think of a local road network connecting houses and businesses in a neighborhood. Number 2 is MAN, that is metropolitan area network. It covers a large geographical area like a city or town. Just imagine a network connecting businesses and government institutions within a city. Number 3 is WAN, that is Wide Area Network. Spans a large geographical areas like a country or even the globe. Think of the internet as a massive WAN connection network that is connected worldwide. Now it connects in two different ways. That is wired network, another one is wireless networks. If we consider the wired network, then devices connect using physical cables like Ethernet cables. Just think of a wired network as a highway system with connected roads. The next one is wireless network, where the devices connect using radio waves or infrared waves or maybe satellite signals. Imagine a wireless network as a communication system using airwaves instead of a physical road. Performance matrices. Imagine a network as a highway system. Here, how we measure its efficiency, it is based on 5 different things. Number 1, bandwidth. Think of it as the number of lanes on the highway. It repeats the amount of data a network can transmit per second, measured in Mbps, that is megabit per second, or Gbps, that is gigabits per second. A higher bandwidth allows for faster data transmission, or you can say data transfer. Number 2 is throughput. Imagine the actual traffic flow on the highway. Throughput is the actual data transfer rate achieved on a network, often lower than bandwidth due to network congestion or inefficiencies. It's like the real-world traffic volume compared to the maximum capacity of the road. The third one is latency, that is delay. Think of it as the time it takes for data to travel from one point to another on the network. It's like the travel time between two cities. Lower latency is desired for real-time applications like video conference or online gaming. The fifth one is bandwidth delay product. This metric combines bandwidth and latency. Just imagine the total amount of data that can be sent in transit at any given time. A lower bandwidth delay product is generally better for applications that require fast response times. Number 5 is jitter. That is, think of an uneven traffic flow on the highway with sudden burst of speed-ups and slowdowns. Jitters refers to variations in latency which can disrupt real-time applications like voice calls. MCQ question. What does the term latency refer to in network performance? Option 1, the maximum amount of data that can be transmitted over a network. Option 2, the time it takes for a data packet to travel from source to destination. Option 3, the variation in packet arrival time. Option 4, the combination of bandwidth and throughput. Give the answer in the comment section. Thank you. Thank you everyone. Please hear the content properly and see the video properly because the content are discussed that you need to hear and the important questions are displayed in the screen which you need to jot it down as well as give answers to the question asked in between the videos in the comment section. Thank you.